We are excited to announce that Terraform Dynamic Credentials is now generally available. Previously, our customers had to manage long-lived static credentials in Terraform Cloud. This added additional complexity and introduced security risks, since it often involved auditing and manual rotation of credentials. To address this, we've just recently released Dynamic Provider Credentials for our official cloud providers and Vault. I'm in the studio with Josh, who works here at HashiCorp as a product manager working on the Terraform team. Thanks so much for being here.
Thanks for having me, Jordan. It's a pleasure to be here to share with this audience this new exciting feature called Dynamic Provider Credentials.
So before we talk about dynamic credentials, let's talk about Terraform. It's one of HashiCorp's most popular products, and for most of the audience watching, they've most likely heard about or used Terraform before. Terraform is the standard for infrastructure automation, and it can be used to provision and manage any infrastructure across multiple clouds. When we talk about the cloud operating model and this infrastructure as code concept, it's really the standard in the industry when it comes to multi-cloud development.
Exactly. Terraform is that standard and industry leader when we talk about the concept infrastructure as code. Standing infrastructure could be a very complex undertaking, but Terraform simplifies this experience by enabling platform teams to automate infrastructure, and by providing a consistent and reusable workflow, platform teams can create, manage, and if necessary, tear down infrastructure safely, regardless of if this infrastructure is in the cloud or on-prem. Terraform primarily uses providers to communicate with virtually any platform or service with an accessible API. And when we talk about providers, Terraform has over 3,000 providers in the registry, so it's fair to say that Terraform can integrate with a vast number of platform and services.
That's great to hear how easy it is to integrate Terraform across clouds. And many of our users are familiar with our open source Terraform GitHub repo that you can download for free. However, there are many more ways to integrate Terraform rather than just using our open source offerings. So, Josh, could you explain the difference between Terraform OSS and Terraform Cloud and Enterprise?
Absolutely. Terraform open source is a very powerful tool when you're just starting to automate your infrastructure. But as you grow and mature in your cloud journey, different needs start to arise. Needs around standardization, scaling process around your provisioning, compliance, and security. Then you want to ask yourself this question, Jordan. Do you want to build a DIY scaffolding around your Terraform open source? Or you want us at HashiCorp to handle this for you with our commercial offerings?
Yeah, so what are some of the commercial offerings then that are bundled and included with Terraform Cloud and Enterprise?
I'm glad you asked. Some of the features that are very important to our customers are accurate cost estimation for finance and procurement teams, team management, which gives our customers the ability to organize and manage their users into teams and also configure permissions around this team. And thirdly, policy as code. Policy as code is used to enforce that Terraform plan complies with security rules and best practices. Depending on your needs, you can opt in for a fully managed solution with Terraform Cloud or the self-managed version with Terraform Enterprise.
Now that we've broken down the differences between our Terraform OSS and Cloud and Enterprise offerings, I think this would be a great opportunity to chat about some of our customers that have implemented Terraform into their stack. So Celio is one that had great results when they implemented Terraform. Their platform team saw a 5x faster time to market, and they were able to decrease time spent provisioning infrastructure. Josh, would you be able to tell us a little bit more about their use case?
Absolutely. Terraform really helps our customers in three main ways. First, increase the speed of provisioning. Secondly, reduce operation and cost and optimize cloud spend. And it also reduces the risk of security or compliance issue. And talking about Cielo, who is a leading electronic payments provider in Latin America, they adopted Terraform to enable their internal teams to collaborate using VCS integrations and to reuse the common modules that were created and shared in the registry.
That's a great point. And another one of our customers, Red Ventures, they've saved over $20,000 a month in infrastructure costs by moving to Terraform Cloud. And using Terraform Cloud, it helped them offload the responsibility of having to run and manage different platforms and services themselves. And this was previously really complex for them because they had over 700 developers managing their infrastructure. So, and many of those developers, right, that we've chatted with at these large companies, they've been asking for this feature, Dynamic Provider Credentials in Terraform. So it's great to see that people like you on our product team have brought this exciting new feature to market.
Yes, previously our customers had to deal with a very tedious process of managing and rotating long-lived static credentials in Terraform Cloud. This added additional complexity and introduced so many risks to their infrastructure. But to address this, we've recently released Dynamic Provider Credentials.
Yeah, so would you be able to tell us a little bit more, Josh, about what Dynamic Provider Credentials means for our customers?
Absolutely. Dynamic Provider Credentials is that feature that offers our customers the ability to generate just-in-time, short-lived credentials for Terraform Cloud runs using the OIDC compliant tokens. Dynamic Provider Credentials is currently available on Vault and all our official providers.
Yeah, and so who are some of our official cloud providers?
And when I say official providers, I mean AWS, Microsoft Azure, and Google Cloud Platform.
Yeah, and so how do these Dynamic Provider Credentials help address the issues with maintaining static credentials?
I'm glad you asked. There are 3 key benefits I want to highlight today. The first thing is it helps to authenticate without having to store your credentials in Terraform. Secondly, it alleviates that burden of manual secret rotation. And thirdly, it reduces the risk associated with exposing long-lived credentials.
Yeah, and would you be able to talk a little bit more about just-in-time short-lived credentials and how they're generated?
Certainly. To get started, our customers have to create a trust bond between Terraform Cloud and their cloud provider. They also have to define the roles and policies on the cloud platform to allow workspaces and runs in Terraform Cloud to be able to access cloud platform resources. So for each plan and apply, Terraform Cloud generates an OIDC workload identity token that carries metadata about the organization, project, workspace, and run phase. During the plan and apply, Terraform Cloud then sends an OIDC token to the cloud platform with the aim of exchanging that token for a just-in-time short-lived credential. The cloud platform then verifies the token by using the Terraform public signing key to ensure the token is genuine and the information it carries can be trusted. Once this token is verified, the cloud platform then returns a fresh set of temporary credentials that can be used to authenticate into the cloud platform. And then the plan and apply can proceed. If that token is not verified, certainly the plan and apply will fail.
Yeah, well, Josh, that was such a great overview of Terraform Dynamic Credentials. Would you be able to show us a demo of Dynamic Credentials working in action?
Absolutely. Very excited to show you the magic behind Dynamic Provider Credential. So the code you are looking at is specifically for AWS using our tutorial. But we have also tutorials in Vault, Azure, and GCP. The first file is defining the infrastructure to establish the trust between AWS and Terraform Cloud. The second file defines some example infrastructure that will be provisioned once the trust is established. We have some variables set up here to properly point Terraform code to the workspace we are going to work with. Now we're going to go to the terminal with AWS Auth already configured and run a Terraform apply to create the trust infrastructure. We'll confirm the apply and grab the outputs role ARN. Now on Terraform Cloud, we have a workspace configured based on our tutorial instructions. We're going to configure the environment variables to enable dynamic credentials and use the role we just created. The first variable is set to enable dynamic credentials for AWS provider. The first variable here enables the functionality and the second specifies the role ARN to use for runs. Now we'll go back to the workspace and queue a run and create the example AWS instance we saw earlier. We see that the plan was successful and we'll create our AWS instance. We can apply this now. And now we see that we have successfully applied and created our infrastructure without having to enter or use a static credential. Finally, we can see that the only thing we had to set up was the AWS role that was set aside for enabling dynamic credentials, and the credentials were dynamically created to complete the plan and apply. This illustrates the tutorial we currently have available on our tutorial site for AWS.
Yeah, that was a really good demo, Josh. Thanks so much for demoing Terraform Dynamic Credentials. And it's great to also hear for all the developers out there that there's great tutorials available on the tutorial site for them to check out today. But where do you recommend going if they want to get started?
I recommend checking out the link located on your screen.
Great. Well, that's easy enough. Thank you so much for coming in the studio to film with us today, Josh. It was great having you.
Thanks for having me, Jordan.